Welcome back to part 3. Let's talk a little bit about formulating an exercise prescription or an exercise dose. Remember, the recommended frequency to achieve or maintain health-related cardiorespiratory goals is 5 to 7 days per week. Some clients will have to work to achieve 5 to 7 days per week. You'll see some recommendations for performance-related fitness that are less than 5 to 7 days per week. But in general, if you have somebody who wants to enhance their cardiorespiratory fitness and we can get them walking 5 days a week for 30 minutes, then that's going to be a very positive thing with likely positive outcomes. This recommendation is based on research that uses MET minutes per week. The overall recommendation using MET minutes is 500 to 1,000 MET minutes per week. So understand that 5 to 7 days per week, 150 minutes of moderate, 75 minutes of vigorous. That's to communicate with the general public. That is based on scientific research using MET minutes so that different modalities can be compared at different intensities. In general, we want between 500 and 1,000 MET minutes per week. So frequency. At moderate intensities, we can do greater than 5 days or 5 days or more. 150 to 300 minutes per week is the general recommendation. For vigorous intensity, you can do less days per week. At vigorous intensities, the body is going to need more rest on days like afterwards to avoid injury. If you are a seasoned athlete, remember, you might be doing vigorous training 5 to 6, 7 days a week. Hopefully you're working in some rest so your body has time to repair. Vigorous intensity, 75 to 150 minutes per week. Gains can be made on less than 3 days, but intensity would need to significantly increase. And for weight loss goals, it may be difficult to reach going less than 3 days. The recommended amount for weight loss goals is 60 to 90 minutes, 5 to 7 days per week. For previously sedentary, greater than 4 days per week at vigorous intensity may increase dropout or injury rate. And that's the problem with a lot of adults that start programs, especially if they do HIIT training. They're used to exercising at the intensities that they did 10, 15 years ago. And so they go at it pretty hard. And next thing you know, they've got a nagging or an acute injury, or they just don't want to continue because it's too hard and then they drop out. So that's another reason why as we get older, it's important to find something that we enjoy doing, to do it frequently and to do it at moderate to vigorous intensities, not always at vigorous intensities. So how do we measure intensities? Well, we can, and these are the ones that you're going to use for your individual training program. Also, I have questions on all of these methods for your test. So I have like what percent VO2 max is recommended in general for health related gains. So make sure that you're making note of those if you are taking notes for these during my lectures. So we're going to talk about percent VO2 max. So if, say 20 METs is your VO2 max, if you determine that using the running test, then at what percent of VO2 max, how many METs should you work out? Based on your goals will determine the percent VO2 max of your ranges. So when you have a client, if their goal is one of 3, it's either health related, physical fitness related, or performance related. Their goal and their present activity level is going to determine the percent of VO2 max you're going to prescribe. We also use VO2 reserve. VO2 reserve simply means you take VO2 max and you factor out resting VO2 max, which is 3.5 mils per kg per minute. We're not going to do a lot with VO2 max for your individual training program. However, there will be a question about VO2 reserve on your test. I'm sure there will be. Then we have heart rate reserve. I'll go over a specific example of that. The cool thing about heart rate reserve is you're going to use your maximal heart rate, and I show you 3 methods to determine that. You subtract out your resting heart rate. So the cool thing about using heart rate reserve is it factors in your present fitness level. So you'll need to do this for your individual training program. You're going to be working with VO2 max for your individual training program. And then we have heart rate max. And again, I'll show you 3 different ways to determine heart rate max. You can do it through a graded exercise test, doing a traditional 220 minus your age, or the Tanaka et al. And I'll show you that in a little bit. Finally, we have rate of perceived exertion. And so rate of perceived exertion is a scale based on the Borg scale. The Borg scale is a scale from 6 to 20, 6 being at rest and 20 being at maximal effort. This is roughly equates to some heart rates right now. Most of you are probably in between 60 and 70 for your resting heart rate. Some of you maybe 76. And then your max heart rate is going to be anywhere around 200, 205, 206. Some of you 202, but this is just a rough estimate. And then we can associate rate of perceived exertion to heart rate. Whenever you're doing these different tests, you can ask, how do you feel? And that's how you get rate of perceived exertion. You'll work with RPE more in exercise physiology lab. The ideal range, though, this would be a good test question, for rate of perceived exertion is a rate of perceived exertion between 12 to 16 on a scale of 6 to 20. Ideally, that's the rate that you would be working out or you would be prescribing. So how about time? Improvements in VO2 max increase with extended duration. So the optimal duration depends on intensity, and that's why we use 500 to 1,000 MET minutes per week. So if you're going at a higher intensity, you can do fewer minutes. So once intensity threshold has been met, the total work, or kcals expended, determines your cardiorespiratory fitness gains. So 30 minutes, as one 30-minute, 2 15 or 3 10-minute sessions is frequently used as a guideline for the amount of duration for aerobic-based physical activity. Remember, if you're working with some clients and time is a challenge, if they don't have 30 minutes, they can do 2 15-minute aerobic sessions and get the same gains, because it all adds to the total MET minutes per week. Let's talk a little bit about VO2 max. So if a subject is working at 24.5 mils per kg per minute, and they have a VO2 max of 35 mils per kg per minute, they're working at 70% of their VO2 max. How do you do that? Well, you simply take 24.5 and divide that by 35 and get 70%. Well, if say you had somebody that their VO2 max was 35 mils per kg per minute, and you wanted them to work out at 70% of their VO2 max, you simply take 35, multiply it by 70%, and you would get 24.5. Okay, so this is how you would use percent VO2 max. Pretty simple. Here's another example. If a subject has a VO2 max of 40 mils per kg per minute, and they're working at 30 mils per kg per minute, they're at 75% of their VO2 max. So it's simply the rate divided by the max to get percent VO2 max. There's also examples in your textbook, so be sure to view those. So for percent VO2 reserve, the reserve is 3.5 or resting metabolic rate. So if in the same one that we used earlier, if a subject is working at 24.5 mils per kg per minute, they have a VO2 max of 35, they're working at 66.7% of their VO2 max, or their VO2 max reserve. So 24.5 minus 3.5 mils per kg per minute equals 21. And then you do the same thing for VO2 max, so 35 minus 3.5. So what we have, so let's talk about percent VO2 reserve. So the R means that we simply subtract out resting. VO2, does anybody recall what that might be? Correct, 3.5 mils per kg per minute. So in the example that we used earlier, if a subject is working at 24.5 mils per kg per minute, we take 24.5 and subtract resting, which is 3.5 mils per kg per minute. And we get 21 mils per kg per minute. And then we take their max VO2, which is 35 mils per kg per minute, and do the same thing. Subtract resting VO2, which is 3.5 mils per kg per minute. How many mets is that? That's 1 met. You're right. And 35? 10 mets. Good. To get 31.56 mils per kg per minute. And when we divide those, we get 66.7%. So the same example where they were at 70%, here they're now at 66.7% if we factor out their resting VO2 or VO2 reserve. Our direct method of measuring VO2 is if we actually know their VO2 and we're measuring their VO2. So measuring VO2 is the only direct. All of the other ones are based on VO2. So if I'm doing a graded exercise test where I'm increasing workload periodically and measuring heart rate, I'll see this relationship because there is a direct relationship between heart rate and work rate after 110 beats per minute. We talked about this when we were talking about cardiorespiratory fitness and we were talking about YMCA cycle ergometer. Okay, so and you'll need to do this for your individual training program. When you plot heart rate and work rate, you can take 60% of VO2 max and get the corresponding heart rate. So the recommendation for heart rate max is 60 to 80%. That's your target heart rate zone. And so that equates roughly to 132 to 156 beats per minute using the graphing method. So then what are some indirect methods for measuring or determining target heart rate zone? Well, we can look at heart rate reserve method. For the heart rate reserve method, we take our maximal heart rate and then we subtract our resting heart rate. In general, people that, not even in general, as a rule of thumb, the more fit you are, the lower your resting heart rate's going to be. So if you have somebody that's fit and you're using the heart rate reserve method, they're going to have a higher level of heart rate to achieve than somebody that's less fit. When we use heart rate reserve method, the percent of heart rate for reserve approximates or approximately equals to the percent VO2 max. Not necessarily the case when we just use heart rate max, but once we factor out resting heart rate, then it's roughly equal to percent VO2 max. We can use the Carvonen method. To use the Carvonen method, we're going to subtract resting heart rate from maximal heart rate to obtain heart rate reserve. Then we're going to multiply by 60 and 80%. When we do that, we're going to add resting heart rate back in. I'm going to show you an example of this, but I want to point out that this is where the number one error occurs. So when people subtract out their resting heart rate, they multiply